or I'm printing a big thing and it's going to have a lot of stress, my goodness, I'm going to need 20, 25, 50% info. Okay? All right, next, skirt and brim. As I mentioned before, skirt is a piece of plastic you're going to throw away. Skirt is a little circle around your object that gives you the opportunity to do two things. Number one, it gives you the opportunity to see if the bed is leveled and the height and the extruder is at the right height. And two, it gives the extruder the opportunity to get going, get started, and make sure that it's spitting out enough plastic. All right? Brim is a related idea, and it relates to the following. Let's say I wanted to print an object that kind of looks like this. It has two little touch pads to the bed, but the object itself is big. If I print it like this, and when I start printing over here, I am pushing the object hard enough that these two little points are just not going to stick to the bed no matter how hard I try. So what Slicer allows you to do is print a brim. Think of a brim of a hat. Okay? It's just basically a large area around your print that's one big solid layer. It gives you a lot more adhesion so that if an object has small contact area, you can still print successfully. I find that I typically print a large skirt of a minimum of 3 loops, typically 4, 5, or 6, to give myself time to react to changes. And I typically almost never use a brim, except for like tall spiky prints that have like, a couple of legs down on the bed. All right? We're going to skip over the page of speeds for now because it's really not necessary for you to print successfully right away. The speeds page, you need to be aware of it and you need to know that it exists and what kinds of things are there. You'll play with it when you try to figure out how to make your print go faster. All right? Typically, the defaults that are there are slow and conservative. They will work, but they will take longer. So when you've printed a few things, you can start speeding some of them up just to see how to control that. And that way you can start making trade-offs between speed and print quality.
Okay. Yeah, I was about to ask, what is the trade-off?
The trade-off is between speed and print quality.
Yeah, okay.
Similarly, there's a tab called Advanced. It allows you to override what Slicer thinks is the right amount of plastic to extrude. Normally, the default settings are fine. However, there's going to be circumstances when you look at your print and you go, it's under extruding because all of the strands are thin and skinny and they don't stick to each other well. Or you could say, well, it's over extruding because the flat surface is all bubbly and yucky looking. And so you can go into this advanced page and tweak the parameters by saying, I want Slicer to take my perimeters and extrude 200%, twice as much as it thinks it needs. Or you only need to extrude 75% as much as you think it needs. I don't want you messing with it right now, but I want you to be aware that it exists. Output options, to the next page. There's a bunch of things here that are kind of interesting, but who cares? Except for one. For things we'll discuss later, you need to make sure that the option labeled verbose G-code is turned on. On. Check mark there.
So nice to talk a lot.
I wanted to talk a lot. Just to give you an idea. There are some circumstances when it's important to be able to look at the G-code and modify it by hand. And to do that, it's extremely useful to have Slicer generate comments in the code.
Okay.
Yeah.
Yeah. I know what's going on.
Does that make sense to you, ladies?
Yeah. But you're having feedback, you're getting constant feedback, or as much as feedback as they're
Well,
gonna give you.
the code assembler is saying what it's doing.
Oh, okay. So like when I used to go into WordPerfect and I used to
You could
like-
see
I could
reveal
see-
codes.
Yeah, I used to like to do that because, you know.
So for example, Slicer will tell you things like, starting layer number 1, starting layer number 2. We're doing perimeter, we're doing infill,
Okay.
you know,
It's
things
like when
like
you're
that.
writing codes and you're writing comments so that later on people can come
Can
back.
find
That's
it.
exactly
and go,
right.
oh yeah, where was the section
And
on
the
this?
thing about it is that it becomes easy to search through the code.
Yeah.
Find the right place in the code where certain things happen.
Yeah.
Yep. All right, so next page, Slicer, filament, main. Filament settings. Filament settings. Are you there?
Yeah.
Okay. There's a couple of things that are kind of but there's a couple of things that are really important. One is filament diameter. Filament today comes in 2 flavors, 1.75 millimeter diameter and 3 millimeter diameter. Your machine is built for 1.75 millimeter diameter. You should always buy 1.75 millimeter filament. However, let's run an experiment. Here's some filament. Calipers. This filament is supposed to be 1.75 millimeter. I'm seeing 1.72, 1.71, 1.74. Nothing is perfect. And filament in particular is far from perfect. Okay? So over time, what you'll discover is that some manufacturers have better consistency, but in any case, it's completely reasonable to take a look at a spool, measure it with a pair of calipers and say, this one's a little thinner. And then you can go into the setting and go 1.71.
Okay.
Okay?
Be as accurate as possible.
Yeah, be as accurate as possible because that helps Slicer generate code that extrudes the right amount of material.
But if it's changing in your, like, you know, what number do you use? Like,
Average it out.
okay.
Take 5 ratings and
Yep. Okay. Please make sure that on both of your configurations it says 1.75 or 1.71 or whatever, something. There is a fudge factor parameter there. It's called override multiplier or extruder multiplier or something. And basically it's this. Slicer is going to do its math and it's going to decide how much it's going to extrude. And you're going to look at the print and you're going to go, nah, that's not enough. So you can say over there, whatever it is that you thought you need, give me this much more.
That's nice.
So when the extruder multiplier is 1, you get exactly what the Slicer wanted. If it's 1.5, you get 50% more. Right? It is sometimes necessary to do that when your machine is a little flaky, some of the older machines, you need to fiddle with it. On your machine, you're probably never going to touch it.
Okay.
Okay? Then come the other 2 numbers that are really important. One of them is extruder temperature, first layer and everything else. And the other one is bed temperature, first layer and everything else. We talked about the different temperatures you need for the different materials. This is where you set them. Now, on some machines, beds are not adequate. They'll warm up, but they'll take a long time, and they will not necessarily reach the temperature you expect. So what I tend to do is I tend to control the bed temperature by hand. I tend not to put it into the profile.
Oh, so there's no number in there?
I would put a 0 in there. Putting in the 0 basically says shut it off, don't touch it. Because if you don't, here's what's going to happen. Let's say you're on this machine. This particular machine is particularly egregious. It has a very, very weak bed. And if I tell it to go to 90 degrees, it will never get there. It'll get to about 72, and it will take about an hour. Okay? And you'll sit there and go, how come it's not printing? This is stupid. The damn thing doesn't work. Well, what's going on is you ask it to reach a temperature it can't.
And so it will literally never print.
It'll never print. It'll just sit there for hours. And it'll say,
Trying to get to a temperature.
heating bed, and nothing will happen. Okay? On your machine, the bed is pretty adequate. You could probably get away with having to setting the bed temperature, and it might take 10, 15 minutes to get to, 100 degrees or whatever.
Is it the thermostat that's on?
It's
Or
not the thermostat.
It's literally not heating up.
It's literally not heating up
The
enough.
heater is undersized,
Yep.
and so it'll just keep, the thing will be full on.
Right.
That's
Keep
how-
cooling before it can ever get.
That's
to
how you get a printer that costs $250.
Oh, okay.
So you undersize all the components.
Okay, okay.
Right? Sometimes a little too much.
Yeah, all right.
So this is where you set the temperature. Most of the time, you'll just set the bed temperature to 0, and you'll set the extruded temperature to whatever it is that your material requires. Now, interestingly enough, these days, material manufacturers will tell you a temperature, but they will give you a ridiculously large range. So for example, Hatchbox will give you a range of 30 degrees. That's completely useless. Yes, I know it's someplace between 210 and 240, but where between 210 and 240? And so what will really happen is you'll do a bunch of test prints with the material, and you'll try different temperatures, and you'll say, oh, Hatchbox Blue PLA tends to print really well at 205. MCM Electronics Stellar Labs Translucent PLA tends to do perfectly well at 198. And you're just going to have different profiles saved for different kinds of materials. So when you print the same material again, you could say, do I have a profile for this guy? What's a good starting point for PLA?
Right.
I start at 205 and work my way down from there. Other people will start at 180 and will work their way up. It's, whatever you happen to like. And whatever your experience tells you is a good thing. Now, there is this whole thing about first layer versus the rest of the model. I tend to ignore that and set them both to the same. That's a level of fine adjustment that I find not to be terribly useful. So, just ignore it. Cooling. Slicer filament cooling setting. So here's what happens. This is a perfect illustration. This rocket has this melty stuff at the top. See, it's really pretty over here.
Yeah.
But it's really ugly over here. Right? Here's what happens. Plastic doesn't turn cold in a snap. It retains heat a little bit. It's called heat capacity. The more plastic you have, the more heat is retained by the plastic. It's based on mass. Again, square cube law. Okay? So what happens is, when the layer is so small that the print only takes a couple of seconds to come around to the same spot, the plastic underneath hasn't cooled off yet. And so when the extruder extrudes more plastic on top, the plastic below starts squishing out. And you get these ugly contours. Now there's two ways of dealing with that. One is to have a little cooling fan, like this one. That's a big cooling fan. To blow on the model and cool it off as you print it, which is great. It's very helpful. I wish I had one on my big one. However, there's also a software solution. And it's right there in that section, in the cooling section. If you look at the small perimeters
On the speed. Right?
down on the bottom, here is what you can do. You can tell Slicer, hey, listen, if the perimeter, if the layer takes less than, let's say, 10 seconds, I know the plastic is going to be too hot, so I want you to slow things down. It's helpful, and together with the fan, perfect. You can get nice, sharp, shiny, pointy things. You're unlikely to worry about it right away, but if you print sharp, pointy things like this, and you see this melty stuff that just looks ugly, that's what it's about, and that's where you go to mess around with it, to get a better looking print.
So we have a fox's ears. You could potentially use that.
You could,
So she's at 10 now, that was the default.
No, it's at 20.
Oh, is that 20?
20, so let's try it and see what happens.
Okay. How would she slow, like, how much to slow it down?
You'll try it, and you'll see. You'll have to mess around with it and see what happens.
Okay, so we should try it out and see what happens.
All right, next tab,
E-bridges, just the E-bridges, fancy, it goes up to 100.
100%, yeah. So there's lots and lots more stuff in there. I don't want to cover everything because as it is, it's been a huge amount of information. It's very hard to absorb. You're going to need to practice with it and then learn and then look. Again, what I want to do is I don't want you to actually understand all of this. I want you to remember, oh, I've heard it's on one of these slicer
Pages,
screens. And you can go back to your notes and say, oh, that's where that.
Yeah.
Okay, the last thing is the printer tab. The printer tab, you only look there once. Once you set up your printer, you'll never look at it again. And the things that are important there are things like bed shape, Z offset, number of extruders, and the connection to a printer server, like Octoprint. Printer servers are kind of cool. They're little boxes that you plug your printer into, and then you don't need to dedicate a computer to it anymore. You can just get a web browser to talk to the printer server, and it works really well.
Oh, wow.
So there's lots of them out there. There's one called Repeater server. That's what we use on our machines. There's also one called Octoprint. There's another one called AstroPrint. There's a few of these. They're all free, open source kind of things that you put on the Raspberry Pi and off you go. So I think Herman, I don't know, is Herman okay with Raspberry Pis and things?
Yeah, I mean, he's pretty good, yeah.
So he could probably build up a printer server
Oh, okay.
so that
Yeah.
you don't even have to keep a printer plugged in. And with a printer server, you can manage typically as many machines as there are USB ports on your Raspberry Pi.
Ah,
So a Raspberry Pi 3 lets you manage 4 printers in one go. So that's really kind of
okay.
One
With two. Oh, this, yes, I know, yes, we only have one of those, yes.
So in general, there's retraction.
Yeah, don't worry about all that stuff for now. It's not that important.
So the only thing to worry about in here is
The number of extruders and the connection to Octoprint, if any. Printer custom code. Basically, there's a way of inserting specific snippets of code in the middle of your print for various purposes. I'm not going to cover it right now because, again, it's too much information, but you need to be aware that that exists, and there will be times when that's important. But that day is not today. Finally, there is a printer extruder setting. That's actually important. There's one number on it that matters a lot, and that is nozzle diameter. You've got to get the nozzle diameter right. On these printers, I believe it's 0.4 millimeter. But it might turn out that playing with that number might give you better prints, because it might be 0.4, it might be 0.39, it might be 0.42.
But we should
And it
just
might
put
matter.
down- We
What?
should just put down 0.4 right now?
At the moment, put in 0.4 and life is great.
Are there times where you really need to measure it, because maybe what they're telling
You
you,
really can't.
you can,
What
okay.
you're going to do is you're going to print an object, a test object,
Okay,
and then based on the results and the looks of it, you're going to say, I'm going to try a slightly larger nozzle setting
okay,
and see what it looks like.
okay.
And then you'll look at it and you go, nah, that's worse. Go back the other way.
And can you damage the machine?
Nope.
Okay, all right.
There's really very few ways that you can damage the machine.
Okay,
Probably the only way that that happens is if you're leveling the bed incorrectly and you drive the nozzle all the way in there and then you drag it across. And the only thing you'll do there is you'll just smush the nozzle.
yeah.
And as I mentioned before, they cost about $5.
Oh,
Go buy another one.
okay,
Unscrew this one, screw in another one, 15 minutes later, you're going.
I don't know. Barnes and Noble one couldn't be able to do that.
And the Barnes and Noble one, you would have a harder time doing it.
$200, okay.
Well, probably not. Okay, so nozzle diameter is the important number here. All right, so after you set all of those profiles, all of those parameters, and saved them all, and you went through and you looked at them, and I would recommend the following. The printer settings, you only do once when you set up the machine and you leave it be. The filament settings, you ought to look at pretty much every time you try a different material or a different batch of materials or material from different vendor. Right? And the only one that you will look at all the time is the print settings, the first tab. So the tab on the left you do most frequently, the tab on the right you do almost never. So once you get them all set, you go back to the slicer page, the slicer tab, and you hit slice.
How do you know it's saved?
So it'll tell you. See where it says modified? You push the little save button next to it, and it will gives you an opportunity to rename or to add another profile with a different name. Just click OK. And go to the filament settings. That one's good. Go to printer settings. That one's modified. Okay, click it. Click save.
Oh,
Yeah, that little blue icon. Yep. You're good to go. You can minimize that. Don't close it, minimize it. Yep. So now, over here, you're going to pick the three profiles that you had. The printer profile, the filament profile, and the print profile. Right? So, yeah, that's it. Where we're going to use PLA. So here is a nice PLA. Is that PLA? Yep, that's PLA.
Do you actually need to put in the color